Today we're going to look at how we can use Docker and Nginx to perform some common DevOps tasks like scaling or blue-green deployments. I pulled this image up as an illustration of some of the tooling that can go into kind of our DevOps day to day. So you got everything from version control like Git or GitLab to containerization, Docker and Kubernetes, to kind of CI/CD pipelines like Jenkins and Travis CI and Circle CI. Although sometimes it helps to kind of go deeper into some of the tools, like how far can we go with just Docker, or how far can we go with just Docker and Nginx combined? And that's what we're going to do today. I'm not going to do a lot of typing today. All this code is in GitHub. I pushed it up to my GitHub repo, and I'll put a link to that in the video, but you can see it here also. My GitHub repo is rcravens, and this particular repository is devops _ Docker _ Nginx. And so all the code is there. And I'm using PyCharm as my development environment. And so what we're going to do is I have the code already pulled down, and you can see the code here. And there's two directories. One is scaling and the other is blue-green. All right, so we're going to look at the scaling part first. All right, in here, there's a very simple Flask app. And this is just an example that we're using to show how you can scale this. Unlike, for example, like a .NET project where maybe you have to have a little bit more complex build system and to get your final package. So the final package here is just an application itself, and it's just a Python code. We're just going to wrap that up and put it in a Docker container, and we'll see that in a second. All right, so if we look at the requirements file, nothing special in here. All right, then let's take a look at this app file. In the app file, I'm just going to scroll down to the routes. We can see the routes here. There's a home route or an index route here, and it just returns a JSON data field with a message saying hello world. So imagine this is an API, so we're just always going to return JSON for these endpoints. There's a ping endpoint that returns a JSON response, a Pong. There's a news endpoint that uses an online API to grab the top headlines for a certain country. I'm defaulting to US, and I think it returns like the top 10 headlines for that country. This is an API-based service, and this is my personal API key. So if you are going to download this, go ahead and just go to newsapi.org and grab your own API key. I would appreciate that. And then there's a weather, which is very similar to the news. I'm using an online API to grab some weather for a city. I'm defaulting to Chicago, Illinois. And again, go grab your own API key if you're going to use this a lot. All of these return a JSON response. And if you go up to a JSON response, you can see it's JSONifying a response. Before I take the response, though, I do add a few new keys here. One is the host name and one is a timestamp. So you'll be able to see some data here changing because of the timestamp, and then this host name will be important when we start to use Docker containers. So inside a Docker container, if you were to run the command host name, you'll get actually the ID for the Docker container. And so it's nice to be able to see that ID in these examples, especially when we start to scale up, we can see which Docker container that response came from. So that's it. I'm not going to cover the app. Again, the app is just kind of there. It could be a different Python app. It could be a PHP app. As long as there's not a lot of building going on. But even if there is build, imagine you can put your own app in here and you can have your own build pipeline to get your package ready. And then what you're really going to do is you're going to containerize that package. It just happens that Python is easy to containerize here. All right, let's take a quick look at that Docker file then. So containerizing this app is pretty simple. We're using the Python 3.6 image. We're adding our requirements file to the image. And then we use pip to install all those requirements. And then finally at the bottom, we add our app, we expose an 8000 port, and we'll come back to this in a second. And then we're using the internal kind of Python server to kind of serve up this Flask app. So if you wanted, you could swap this around and serve this with gUnicorn. It's up to you on which one you do. I was using this one because I'm in development environment, and then I was getting some logging that I wouldn't necessarily get with this gUnicorn. There is one more service. We're using Nginx, like I said before, and the Docker file for Nginx is pretty simple. We're just using an Nginx image. We are deleting kind of the standard or the default conf for Nginx, and then we're subbing in our own conf. And we're going to look at this Nginx conf in just a second here. But before we do that, let's take a look at our Docker Compose file. Docker Compose, we're setting up a kind of a Flask app network here so that all of our services, they're all on the same network and they can talk to each other. We see that the first service is the app itself, and we're just building it using our Docker file that's inside of our app directory, and we're adding it to the Flask network. And then one of the things about the app that you're going to see is we're missing a container name. Because I want to be able to scale this, I can't hard code a container name in here. I need Docker to be able to name our container in this case. So there's no container name option in this YAML file. And the second service that's in here is Nginx. And here we do set a container name for it. So here we're telling it where the Docker file is. You can find it in the Nginx directory. We are exposing ports. So port 80 on the outside is exposed to port 80 on the inside. If you have port 80 already used on your machine, feel free to go ahead and switch this to something else. I have port 80 open, so I'm just leaving it. And there's a dependency on the Flask app itself here. And so before Docker actually spins up the Nginx service, it'll spin up the app service first so that that's ready. And then we put it on the same network. So it's pretty simple. All right, so let's take a look at this Nginx conf file. So I just want to focus in on these lines here. And in particular, in line 16, we set up a variable called upstream, and we set its value to app. And if you look at how we're using this upstream variable, any requests, so HTTP requests that come into our server, anything, / will capture everything, we're going to pass it over to a proxy with this upstream variable and at port 8000. And port 8000, because that's where we started our Python service. So we're starting up our web server on port 8000. And so upstream has to be the host. And so Docker resolves this name because that's the name of the service. So if you look over here at services, we call our service called app. And because of that, Docker will help us resolve this to a host name, which it'll put in there for us. And so Docker really manages behind the scenes kind of that kind of DNS resolution for us. So with that, we've covered all of the directories here. So I'm going to close down everything. And the only thing I'm going to open up is I want to open up this README file, because the README file kind of gives you instructions on how to really kind of use the application. Not really talking about the code like we just talked about, but just how to use it. So I'm going to change into this directory here. And then what we're going to do is we're just going to start by running this first command. And I'm going to drop this in here. Before I run this, Docker compose. So it's going to use the compose file that it finds here. And up, it's going to start all of our services. -D means I want to run this in daemon mode, or detached mode, so I'll get my prompt back. And then I give it the build flag, so it's going to build everything. And so we're going to run this and let it kind of do its thing. It may take longer for you. I have all these images already kind of cached on my machine, and it starts up pretty quick. And then what you should see in your Docker desktop is you can see kind of our app. We have app 1 and we have Nginx. All right, and so now if we go look at the output, I'm going to go to the localhost /ping route, and if I update this, I'm getting fresh data all the time. And you can see the timestamp is being updated. I'm getting the Pong request from my ping. And then the host variable here, you can see that matches the value for the Docker ID for that container. And then you can play around with the other routes. So if you want to hit the news route, you can see kind of the top 10 headlines for the US. And the weather route will default to Chicago. So you can see Chicago, Illinois, the station's in Chicago. All right, so I've arranged my windows so we can see everything all in the same screen here. So on the right-hand side, I got the app, just using the ping endpoint because that's a little less noisy than kind of the news and the weather. But what you can see is every single time I refresh this, Nginx, which is one of our services that's running, is forwarding that request over to the only application that's around, which is that 447C7F and it's here. And so that host is receiving all those requests. Let's say, imagine now one day everybody wants to use my Pong feature and it's becoming overloaded. So what I can do is I can scale up the app, and I'm just going to copy and paste this. Okay, so before we run this, let's decompose what this command is doing. So I'm using Docker compose. So that associates it with that compose file right here. Docker compose up. So I want to start something up. Then I'm going to run this in detached or daemon mode. And then I'm giving it some options. So I'm seeing scale the application service, the app service, and I want to set it to 5 instances running. And then this last flag, -- no recreate here, is kind of one of the tricks, is because I want to have 0 downtime when I scale this app up. I want to add 4 new services, but I don't want this other service to kind of go down. I definitely don't want Nginx to go down. So you can see that 447C is the starting point, is the start of the ID for our current app. After I run this, if you take a look over here in the Docker desktop, you can see it says, okay, well, this one's already running. I need to start 4 new ones, and this container's already running. So it doesn't really restart the other containers, but now you can see I have an app 1, 2, 3, 4, and 5. And then as I refresh my URL, notice it'll start to change. It'll bounce between app 1, which is again 447C. All right, so now that I've got my other apps up and I've scaled up my application, when I refresh my URL, you're going to see the host is changing. And so Nginx is now proxying my HTTP request to one of the available services. So Docker has scaled up our application by adding 4 new instances of our app running on the same hardware. And so this type of scaling helps in certain situations, but it doesn't help in situations like, if I were already CPU bound, for example. Say I run in one instance of our app on whatever hardware that I have sized out, and I'm maxing out the CPU. Adding 4 new instances of the app is probably not going to help in that case. In that case, I probably would want to maybe add CPUs before I scaled out in this way. All right, so now that we've scaled up, let's scale it back down. And again, I want this to be seamless. So I'm going to use kind of almost the same command, but this command, all I'm doing is I'm setting the scale to 1. And then when I do that, all of the other containers will disappear and I'm back down to my original. And so you can see as I refresh here, now I'm just kind of being directed to the one application that I have. And then finally, it's easy to just shut everything down. So I can Docker Compose down and it'll shut all of those applications down. So that's it for the scaling app. So now let's cover the blue-green deployment app. First of all, we'll focus in on just the differences here between the scaling app and the blue-green deployment app. So in the blue-green deployment app, there's 2 versions of the application. One is blue, one is green. And the only differences between this and the application that was in our scaling app is I added a new dictionary element called _version, and it's blue for the blue app, and you can guess it, it's green for the green app. That's the only difference here. And so you can imagine maybe this is version 1 and this is version 2 of your application, however you want to do it, but there's just some small differences here. And the goal here is that we want to be able to deploy whatever version's not deployed seamlessly. Let's say we start off with green deployed, and then I want to switch it over to blue, and I want 0 downtime. And then nothing else has changed about these apps. The Docker file is the same, the requirements are the same, everything else is the same about these apps. And so the next thing is let's take a look at the Docker Compose file. There's only a couple of small differences here. We're still building the network, but now I have 2 apps. I have a blue app and I have a green app, and they just point to their own respective directories. And then down here, I'm saying depends on both of those. So when I run this thing initially, both of them are going to start up. It doesn't have to be that way, but that's just how it is going to be out of the box. We're going to run it that way. So that's the only differences here with the Compose file. So now let's look at the differences in Nginx. So if I look at the Docker file, I'm deleting the default comps, and then I'm copying our 2 new comps. So I have a comp for the green app, and I have a comp for the blue app. So I'm copying them both over to Nginx, and then I'm setting a link. So this is a symlink from the green app to nginx.conf, which is the default one that it's going to use. So out of the box, when we start this up for the first time, what I'm expecting to see is the green app will be running. So let's take a look at these 2 files now. So look at the green app first, and the blue app, we're going to pull it up in a second. It's going to look almost the same thing. So instead of having 1 variable, we now have 2. And again, we use these host names that Docker will resolve for us automatically because these match up to the service names in our Docker Compose file. So app green, app blue. So if you look down here, at the / location, which is, everything that comes into Nginx is going to get forwarded over to the blue app. And if you look at the green app, that's what changes here. If you switch back and forth between blue and green, you can see that that's the only thing changing between these 2 different files. So one file forwards everything over to the blue app, the other file forwards everything over to the green app. And these things in the middle, I've set this up so that we can actually see both apps. So if you go to /blue/ping, you're going to get forwarded over to the blue app. If you go to /green/ping, you're going to get forwarded over to the green app. These are unnecessary, but those are helpful for kind of debugging so you can kind of see everything going on. So let's close up all the tabs, and then we're going to just open up the README, and we're going to get started here with the README. It starts off the same way. I need to switch over to my other app though. All right, so we're going to let this build. Starts up. Over here you can see I got Nginx. I got the first instance of app green and the first instance of app blue running. And if I go up here right now and I go to my host, when I hit it, I'm resolving to the green app. And it's resolving to green because if you remember, that's the first one that we symlinked in. So we're symlinking in the green conf. And so that's why it's serving up green here. So we're using this conf right now, which is forwarding over everything to the green. But we have these other endpoints. So we can try this endpoint /green/ping, and that's the green app. And I have this other endpoint going /blue/ping, which is being fed by the blue app. So in this instance, I have access to both. So I can see green, I can see blue, but then here's production. So imagine this is our production. And then to switch over from our green app to over to the blue app, really the only thing that has to change is I have to change this symlink over to kind of the opposite. So every time I want to deploy the other one, I need to go Nginx blue conf instead of green. And that is what this swap deploy script is doing. There's not a lot in here, so the first thing I'm doing is I'm running this command, and we're going to take this and just run this on the command line here so you can see. So Docker compose exec means I want to run something inside of a container. So I want to execute something inside a container. The container I want you to execute this inside of is Nginx, and then I'm going to run this ls-la/etc/nginx/conf. And this is the response I get back. So if I run that inside the container, I'm going to get this string back. And then if you look down here, I'm going to conditionally deploy, depending on the string. If I see the word green, which I will, so I see the word green in this string, I'm deploying blue. Otherwise, I'm going to deploy green. We're going to find green. So we're going to get into this, and then I'm going to run another Docker compose exec command on the Nginx container. And the command I'm going to run is I'm setting this symlink to blue. So it was green, now I'm going to sort it to blue. And if it was blue, then I'm going to run this command instead, which sets the symlink to green. The only remaining thing to do is we ask Nginx to reload its conf files. And so once it does, it'll start pointing it over to the other one. So right now I haven't run anything. It's running at green. If I want to switch it over, I swap the deploy. When that's done, it says deploy in blue, and then this is now blue. And you can see it can go back and forth. Now it's back to green. So the other thing that I'll cover is imagine that this is production. And let's say we've already scaled this thing up because we need 5 instances. So I can scale the blue app up 5 instances, and it'll create 5 instances of the blue app. You'll see it over here. Now I'm not running the blue app right now, so I'm not hitting any of those instances. I'm just hitting the single instance of the green app that I'm up. But now if I deploy the blue, now you're going to start to see Nginx is proxying between the 5 different instances of the blue app. And again, I can scale back down to 1 instance of the blue app if I want. So 1 app, blue app. So it'll drop the other 4. And now if I refresh, I'm just getting 1 instance of the blue app. Now right now I'm running blue. And if I wanted to, I can shut green down. And so I can just run this to shut the green app down. So the green app container has now kind of been shut down. The image is still around, but now if I hit my endpoint, my blue endpoint continues to function. My green endpoint, this one is going to have an issue, and my blue endpoint will continue to function. And then we can also do the opposite. So if I want to start my green app back up, I can run this. This dash build is going to rebuild the image, but it's not really necessary if it's just the same container. And now green's back up and running. Again, production's still on blue, but now that should fix my bad gateway here that I had on green. And you can see here my blue is still running. So that's it. That's an example of how to do blue-green deployment using just Docker and Nginx. And finally, if I want to shut everything down, I can run Docker compose down to shut everything down. And everything's gone. So that's it. So right now we've got scaling and we got blue-green deployments, all on kind of using just Docker and Nginx itself. So if you have any questions, comments, concerns, feel free to leave a message below.